or inductive, right, with an I. Today, this is going to be called, this is going to be called deductive reasoning. Okay, so what's the difference? What did we do by inductive reasoning? When we did inductive reasoning the other day, we were looking at conjectures and educated guesses, right? So we were looking for patterns that could maybe prove this. So this is where we were going to sit down in front of school and have a survey as people walked into the door. Well, deductive reasoning, where we're going to talk today, is more about facts. Okay, so this is actual facts that back up something happening. So if Jamal goes to the ball game, he will not go to the movies. Jamal went to the ball game, what is your conclusion? He didn't go to the movies, right? Okay. How about the second part? If Sam goes to the ball game, he will not go to the movies. Sam did not go to the movies. Did he necessarily go to the ball game? Not really, right? So just because he didn't go to the movies, we don't know about him going or not going to the basketball game. But if he definitely went to the basketball game, then we know that he doesn't go to the movies. So this is a fact, right? We could actually go to the basketball game and see if Jamal was at the basketball game. If he's at the basketball game, we know later on that he won't be at the movies. But if we go to the basketball game and he's not there, is it a certainty that he goes to the movies? Either. No, right? So he could still go out and go to supper or something. So what we're going to look at is the difference between the two. And like I said, so deductive reasoning is using facts, rules. So this would be like some kind of definition or property. What do we mean by properties? Okay? And we're going to use those things that are true about whatever we're talking about. Definitions is what you can look up in like a glossary or an index, right? The rules of something, you can have a list of them, and if you follow them, they should actually show you what you're going through. So with this now, deductive reasoning, we have two things that could happen. Number one, it's called the law of detachment. So we'll go through more examples of this here in a little bit. In the law of detachment, we're going to go back and use our if-then statements. All right? So in this, remember a conditional is our if-then statement? If the conditional is true and the second hypothesis or sentence is true, we assume that our conclusion is going to also be true. So what this is saying is, in the law of detachment, we're basically going to say P to Q again. So if something, then something. Right? That's what we've already learned. And what we're going to do here, if P to Q is a true conditional, so we go through, we read it, we understand it, just like what we did in the last section. So if this is a true conditional and P is true, then we would assume that Q has to also be true. So if the whole thing's true, the individual parts are also true. And remember, the P basically is my hypothesis. The Q is basically my conclusion. So if I read through my if-then statement, I come to the conclusion that the whole thing's true. Then I come to the conclusion that the P part, or the part with if, is true, and individually, the Q part is also true. And we would build on that. Okay, so if the facts are given true facts, the whole thing ends up being true. And then you're going to compare this to the next sentence that is given to you. So you're going to be given like two conditionals in the law of detachment. You're going to read the first one, determine if it's true or not, and if it is, then they might change the sentence, but essentially say the same thing. So the law of detachment to me is making a general statement and then doing the same exact statement, but getting more specific. So an example of this would be something like if I was talking about a car has four wheels, be a true statement, right? And then my specific statement would be, name a car that's specific. A Chevy Impala has four wheels. So I just got more specific. I said the exact same thing, but I actually named what kind of car it was. Okay? So in this, we're just seeing if it's all true. And then we compare it to the second one to see if it's all true, but it's just getting more specific. Okay? So real general to real specific. Now, here's the kind of weird parts, right? Even though a conditional is true and the conclusion is true, doesn't always mean the second hypothesis is true. So you might go through and you might read your general statement. A car has four wheels. And then they might get specific. And they would say a hovercraft has four wheels. Well, a hovercraft wouldn't have any wheels at all, right? But you could still consider it maybe a vehicle. So even though that my general statement is true, the second statement, where I got specific, might not be true at all. And so they're just going to change it that way. So that's one way that they could do it. If the second sentence is a conclusion instead of the hypothesis, then the statement has no conclusion. So if you went to this right here and you said, again, a car has four wheels, and your second conditional said, there's four wheels on a truck. Well, the four wheels was my original conclusion, so they flip-flopped them. And if they flip-flopped them and make your original conclusion into a hypothesis, then there's no conclusion that I can really make. So they're basically going to ask you to fill in some blanks in this part. Okay?
Sound like SpongeBob.
I was going for that. If the second sentence is a hypothesis that isn't true, then that means the whole statement isn't true. So if they come back here, they give you a general statement, you read it, you think it's true, and then they come back and they say something totally different. So go back to your banana is blue thing in one of our examples the other day. Is my banana ever going to be blue? No. So then my specific statement is totally false just because the first part of the conditional is false. Okay, so again, we're getting really, really generic statement to a really, really specific statement. All right, so I know this might be confusing. So let's look at a bunch of examples here. Where are you going to go there, big boy? That's good. Just turn that way. You're fine, right there. Can everybody see? All right, first one up here starts back to my kind of car one. So if a vehicle is a car, then it has four wheels. Okay, do we agree? If a vehicle is a car, then it has four wheels, true or false? Could be false in this day and age, right? Because you could have one of those tricycle motorcycles, right? But in general, let's just say that we agree with that. We're back into the 1980s where nothing has been invented yet. Scientifically cool, right? So if a vehicle is a car, then it has four wheels. Now, instead of saying a vehicle, we specifically say a sedan is a car. We're telling you that. So what conclusion can we make? It has four wheels. Okay? So again, we said a general statement, and then we got specific. We even got more specific in the one that we talked about. How about the next one? If a student turns in a permission slip, then the student can go on the field trip. Would you agree with that? Okay, that sounds about right. Felipe turned in his permission slip, so what conclusion can we make? He gets to go, right? If a person is a Texan, then he is an American. Would you agree with that? Okay. Jim is a Texan. We would then just say Jim is American, right? He might have different beliefs than us, but it's true. So again, look, we go real generic, some person, and then we got specific by naming that person as Jim. Yeah? If October 12th is a Monday, then October 13th is a Tuesday. True? Except for Lauren, because she skips some days. October 12th is a Monday, so what do we say? October 13th is a Tuesday. Now this one right here is kind of weird because they basically just say the same thing over and over again. So it's still the law of detachment because you can't get much more specific than the day that they already named. And that one. So this one still could be the law of detachment because we said something, it was all true, and then the next thing was all true also. All right. I know you still might be confused. It's all right. This is a confusing one. We'll get to more here in a second. So the second way, so again, specific to real or general to real specific. The second way that you can do deductive reasoning is the law of, and you're going to like saying this word, syllogism. So in the law of syllogism, this is comparable to the transitive property. Do you remember the transitive property? Anybody? The transitive property says if I have something A and it's equal to B, and then I show that B is equal to C, I can take that B out and then say that A is equal to C. Remember that? So, let's write it down. If A equals B and B equals C, then, again, I like to say I'm plucking out the B's in the middle, and what's left over? A is equal to C. So some people don't like this because there's just a bunch of letters. So mathematically, this would be if 4 plus 3 equals 5 plus 2. Agree with that? They're both 7. And 5 plus 2, because look, B has to stay the same, is equal to 6 plus 1, still 7. Then we know that 4 plus 3 is equal to 6 plus 1. That's the transitive property. I'm plucking out the things that are the same, and then whatever's left over should also be equal to itself. Okay? So in conditionals, this is if P is to Q, so we make some kind of statement, a conditional, that P is to Q, and Q is to R, then what? Again, just like the transitive property, we're going to pluck out the Q's, and what's left over? Then P should be to R. Should also be true. So if this is true and this is true, when I pull out the Q's, the beginning and the end of the original and the second one should also be true. So again, when I hear the law of syllogism, I'm thinking the transitive property. If I can pluck out something in the middle and take the beginning and the end and make a new sentence, then I have the law of syllogism. Couple different things in this one. If the conclusion of the first statement is not the hypothesis of the second statement. So if you start writing these, if the conclusion of the first statement is not the hypothesis of the second statement, you can't do the law of syllogism. It just doesn't work. Make sense? And then if that's true, you would just say this is not valid. The whole thing is wrong. Okay? So if Q is hypothesis of the first, but not, or sorry, no. I should say conclusion of the first, but not the hypothesis of the second. And again, when I say first and second, I'm talking about the first conditional to the second conditional. Then the whole thing is not valid. Now, ladies and gentlemen, don't just put not valid for all of them.
Well, I read it and I didn't think it worked.
Okay? You're not going to have not valid for very many answers. Okay? If you look back in the quiz and you had not valid for 5 of the 6 answers, go back and change it. Okay? So, does this one make sense? This one makes a lot more sense to me here. This one, kind of confusing once in a while to me. Because the law of detachments, even though that I say some general statement, they could repeat that general statement and it's still true. They could get specific and it's still true. This one, pretty straightforward to me. If these two things, I can't just physically pluck out of there or erase and make the first and the second thing make sense, then it doesn't work. Okay? So let's look at some of these ones. Got enough room there? All right. So can a valid conclusion be reached from the two statements using the law of syllogism? If Elena takes the car to the store, she will stop at the post office. Can't really argue that. Everybody okay with that? If Elena stops at the post office, she will buy stamps. So, if you look at the two conditionals that were given, is the conclusion of the first sentence the same as the hypothesis of the second sentence? In our example. So, if we pluck that out, which is what? Stops at the post office. What sentence can we rewrite now? She will buy stamps. Okay? So, the conclusion that we come up with, because of this, makes a true statement at the end. Now, will it always happen? It says it will. But we don't guarantee it, right? If she takes the car to the store, maybe she has an accident and doesn't make it to the post office. You know? But by what they presented to us, it should work. Okay? If Rachel lives in Tampa, then Rachel lives in Florida. Would you agree? The only argument you can have is what? There's a Tampa, Iowa. Alright? So you could be a smart aleck and say, well, there's a Tampa somewhere else. Which is true, maybe too. But this statement that they make is true, right? There is a Tampa, Florida. Okay. If Rachel lives in Florida, then Rachel lives in the United States. Would you say this is the law of syllogism? Is those middle two things the same thing again? If I look at what we said, don't we match up right here? Right? So if I pluck that blue part out, what's left over? Exactly right. Make sense? And does that make sense? Is that a true statement? If she lives in Tampa, whether it's in Iowa or Florida, does she live in the United States? Yes. All right. If Henry studies his algebra, then he passes his test. Some of you might say this is false no matter what, because you know who Henry is. And as much as Henry wants to study, or how much you study, you might still not pass that out of the test. But if we go with it, if Henry studies his algebra, then he passes his test. If Henry passes his test, then he'll get a good grade. Is this the law of syllogism still? Yeah, because he passes his test. So we would say then, if Henry studies his algebra, he should get a good grade. But again, good grade has its own meaning, right? With some of us. Okay? So, the last part. Now we're going to try to do and be specific and say which form of deductive reasoning we're doing here. Okay, so determine if the statement 3 follows from statement 1 and 2 and by which measure. Okay? So, statement 1, if the measure of an angle is greater than 90 degrees, then it's obtuse. First off, true or false? Everybody agree? Okay. Second statement says, the measure of angle T is greater than 90 degrees. So, think about this. In a sense, what they're saying here, if I did 2 and 3 together and made another conditional, if the measure of angle T is greater than 90 degrees, then angle T is obtuse. Would you agree with that? Okay. So, did we get specific from the first statement to the second by naming that angle, or did we take a middle section out and basically rewrite something? We got specific, right? We named that angle, right? That obtuse angle, we called it angle T. So we would have said this one was the log to 10. That makes sense? Okay. If Pedro is taking history, then he will study about World War II. True or false? Right? Could be, could maybe not be, depending on what history course are, right? What's mush all about? You guys aren't mushers yet. You're, some of you are, right? Modern U.S., right? Okay, so you probably don't talk about World War II, but in some history class you might. Okay? So, if Pedro is taking history, then he will study World War II. We're going to say that's true. Pedro will study about World War II. So, Pedro is taking English. So, the first one, did we get specific? Not really, right? Did we have things that matched up in the middle? Then he will study World War II, and Pedro will study World War II. So we can pluck that out, right? But does it make sense? Not necessarily, right? If Pedro is taking history, then Pedro is taking English. Doesn't really make sense all the time, right? So you're right, this one's inconclusive. Because it just doesn't really make sense. Next one. If Julie works after school, then she works in a department store. Might not be true necessarily, but they're telling you this is her case. Okay? Because she could work other places, right? If she really wanted to. But we're telling you this is her case. Julie works in a department store, so Julie works at Target. So, again now, are these two things basically the same thing? She works at a department store, she works at a department store? So, which one would we say this one is? The syllogism, and then what would we say for our last conditional?
If Julie works after school,
She works at Target. Okay? So even though we did get specific in this one, it's still more the law of syllogism because we can pluck that stuff out of the middle. Okay? I think there's one more. If William is reading, then he is reading a magazine. So the only thing that William reads is magazines, evidently. He doesn't like to pick up a book. He doesn't like to pick up his school books. Right? If William is reading a magazine, then he is reading a magazine about computers. Which one do you think? Did we get specific? Is there two general or two if-then statements? Yes? Did we get general to specific? Should I take it out though in this middle? So you think it's both? In a sense, it's kind of both, but if I can take it out of the middle, we're going to go with the law of syllogism. And so, yes, this one kind of gets more specific when we do P to R, but it's because we can pull that common sentence out of the middle that this is the law of syllogism. The law of detachment will be very, very evident, saying two specific things at the beginning and two specific things at the end. Okay? But getting general to more specific. This is one thing right here. Lauren's going to ask again, why do we have here? You're never going to use it. You're stupid. Right? But the main objective of this section right here is to get you to start thinking in a different way. Okay? To actually read sentences and form thoughts in your head where you might have to work through some problems. So, will you ever use this necessarily? No, you won't. Unless you're going to be a math teacher. And I don't think Lauren is, no offense. Okay? So, why does she have to do this? Because it's a homework assignment. And guess what? You're probably not even going to have to do this on the quiz or the test. Okay? But it's just a way of thinking. So, do you want to see more examples of this? Anyway. So, don't get frustrated when you're doing the homework today. Please. And read the problems carefully. And talk through this with somebody. Honestly, if you have a chance to read this out loud, read it out loud. I know you might look weird in study hall. That's okay. Just tell them, hey, I'm doing math. And then they'll understand. Right? So there's your assignment. But if you want to see more examples, we got plenty more examples of this too.